So a linked list is a dynamic data structure. We can represent nodes and edges between nodes, but equally we're reading this like a list. And the reason it's linked is because we can move up and down the list in really quite a dynamic way. It's easy to change the data set. It's easy to sort of add and remove from this. So really kind of quite a versatile data structure. So here you can see at the bottom here, this is just a graph that's been represented. What we have then within this is that we are starting from from 3. And that means that in the table here, we start at line 3. From line 3, we can see that Hull has been displayed, and therefore it's now going to point to line 1. So in other words, we're going to go up here. From line 1, we go to line 4, down here, and you can see that we're moving quite dynamically around the linked list. From 5, go to here, from 2 up to here, and then here we've got a null, and therefore we stop. And that represents this below, okay? So really quite a nice way of keeping data. So in other words, what we were able to do is just keep adding to the list, so the list doesn't need to be sorted in any way, but the pointers enable it to be sorted for us. So it can be for different reasons. In this particular one, perhaps it's just a route, a train route, for example, or we could then quite easily put it into alphabetical order. Again, we'd just change the pointers to represent that change. If we want to add, we can see here that the leads has been added. So all that's happened is that this pointer has changed to include the new line of 6, and therefore Leeds now points to Liverpool, and therefore has changed to go in there. So you can see that Leeds was just added to the bottom of the table, and therefore links across. We can delete easily as well. So you can see that Aberdeen has been removed, and therefore instead of pointing to Aberdeen, Hull now points directly straight to Manchester. So in other words, the Hull on the table of line 4 points to here, the line 4 of Manchester. Comparisons between these. So an array officially is static data, though we do know you can make changes to it to a degree. A linked list though is dynamic, so it's dead easy to add to, dead easy to change. But again, there are certain advantages and disadvantages to this. If you want to find a data item in a linked list, you need to traverse through that in a serial search. In other words, you have to go through every single part of the list to check, is that data there? Whereas, again, other data structures don't have that issue. You can go directly to a particular index. So in the case of an array, for example, you can go directly to an index and check, is it there? Again, a linked list data isn't stored contiguously, so it's not necessarily together in memory either. It's just being pointed to a new memory location, whereas in an array, they're all grouped together in one place. Okay, well, I just wanted to say thank you for watching. I really hope you found it useful and really hope you've learned something. Please do like and subscribe, and I'll hopefully see you again. Thanks a lot. Bye.